Hello, this is Mr. Stansbury. I'm going to take you through the notes of properties of similar figures. At the end of this, you should be able to say, I can identify and apply properties of similar figures. All right, similar figures. Similar figures are denoted by this little squiggle sign, which is similar to the congruent sign with the equals underneath it is congruent, but without the equals underneath it, that means similar. Okay, so similar means all corresponding angles are congruent and all corresponding sides are proportional. They don't have to be congruent, but they do have to have the same proportions to each other. Okay, so ratios must be set up with corresponding parts. So like let's say if we have that these two rectangles here are similar, then what we would do is we set them up. So you can either set it up as the short side compared to the other short side, so a over x equals the big side to the other big side, b over y. Or you can go a over b equals x over y. And then one way I've done this in the past that could possibly be helpful is like when I'm setting up a proportion, I'll just write like, say, here's the big, for example, on this one, this is the big rectangle up here, and then this is going to be the small rectangle down here. And on this side, I'm going to write the short side, and on this side over here, I'm going to write the long side. So if I were to do that, on the big triangle, the short side is A, and on the big triangle, the long side is B. And on a small triangle, the short side is X, and then on the small rectangle, sorry, not triangle, the long side is Y. So that's how you can set it up. Or you can set it up like this too, that's fine. Okay, with that. Triangle DEF is similar to triangle XYZ. Show which sides are proportional with ratios. So what we're going to do is we have to show our proportional sides. So remember, the order matters here. So we know that DE is the same as XY. So let's do, say, DE is to XY as, let's say, EF is to, let's see, that would be YZ, right? And that should be the same as DF and XZ. DF and XZ. Okay? So that shows that these triangles are proportional with our ratios here. Okay, another example, the rectangles below are similar, find x. So you do not have to do it this way, but this way will make it fairly foolproof. So I'm going to do this. I'm going to do the small one on the top, and I'm going to do the big one on the bottom, and these are the rectangles. So then I will do let's do the short side over here, and we'll do the long side over here. So if you do this, you're pretty much guaranteed to set it up correctly. So small triangle, short sides, triangle, rectangle, small rectangle, short side is X. Small rectangle, long side is 12. And then on the big rectangle, the short side is 6. And on the big rectangle, the long side is 18. Okay? If you have a one ratio equals another ratio, I would say your best bet is to do cross multiplication. So I'm going to do 6 times 12 and set that equal to x times 18. So 6 times 12 equals x times 18. Okay, so that's 72 equals 18x. Divide both sides by 18. Right, so we get 72 divided by 18, and we get that x equals 4. Okay, so and let's make sure that's what we're looking for. Yep, find x equals 4. And then we'll take a look at this one here too. Okay, this one here, triangle ABC is similar to triangle LMN. Find the measure of angle C. So let's see, they give us that M here is 57. Let's see if we can fill it in over there. So M is in the same spot as B, so this is going to have to be 57 degrees here. And then to find C, we know that if we add these two, 57 plus 64 plus the measure of angle C. All three of these angles in a triangle always have to add up to 180, right? So let's figure that out. So we'll do 57 plus 64 is 121, plus the measure of angle C is 180. Subtract 121 from both sides, and we get that measure of angle C has to be 59 degrees. Okay? All right, got one last example here, but let's watch a funny video first.
Stuff you gotta get a good picture.
I told.
All right. Kate is about to meet with her final client of the day. She needs to create a wall mural. She can measure the length of the wall, but not the height. She has a prototype picture and knows that the wall and the picture are similar rectangles. Kate needs to find the area of the wall. Okay, so here's the wall, here's the prototype. Which of the two rectangles, which sides of the two rectangles are corresponding? Okay, so we know that this 14.1, that's the bottom of both of these, so these would be corresponding, and so would this right side to this right side, right? Okay, so we just wrote that down there. For part B, write two different proportions that can be used to find the height of the wall. So we can do this. Let's say we can do the big mural, or let's do this. Let's do, instead of big, let's do the wall, and then the prototype, right? Setting up a ratio here, and then on the wall we can have, say that this can be the bottom, and then this could be the right side, right? So on the wall, the bottom is 14. And then on the wall, the right side is what we're looking for, the X, right? And on the prototype, the bottom is 31.5. And then the right side is 18 inches. Okay? So that's one ratio that we can set up. We could also set it up like this. We could also set up, kind of just move these things around here. So we could do the right side and the bottom. And then over here we can have, say, the wall one. And then over here we could have the prototype size, right? So the right side of the wall is the X. And then the right side of the prototype is 18. And then the bottom part of the wall is 14 feet. And then the bottom part of the prototype is 31.5. Okay, so that's a couple different ways that we could write that. All right, C, reason abstractly and quantitatively, can the proportion X over 18 equal 31.5 over 168? So, let's see, they've got, here's our X, right? X is to 18. X is to 18, so now it's going to need to be the big one, the big side, over the little, because they did the wall over the prototype, so we got to stick with wall over prototype. So that would have to be the 14 feet, which they turned into apparently 168 inches. These need to be flipped around. So can this proportion be used to find the height of the wall? Nope. Because they flipped it around, right? They've got the wrong piece on the wrong side. So corresponding sides are not in the same position in the proportion, right? So no, corresponding sides are not in the same position. Are not in the same position. Okay. What is the height of the wall? Show your work. So we can use either one of these, doesn't really matter. And really, you know, since this here, these are both in inches, these are both going to be in feet, we do not have to convert these. We should be okay without that. So Let's just do this one here. I'm going to do this times this equals this times this. And if you'll notice over here, x times 31.5, 14 times 18, they're going to be the exact same thing, right? So if we do that, and then we move this info up here, that's going to be 14 times 18 is going to equal 31.5 times x, right? So we just got to figure out what 14 times 18 is. And that is 252 equals 31.5x divided both sides by 31.5. And that should tell us what x is. So take that, divide by 31.5, and we get that x, this side here, is going to be 8 feet. 8 feet. Okay? All right, and then the last part says, what is the area of the wall? Show your work. Area of the wall is length times width, so that's just going to be 14 times 8. So 14 times 8 gives us 112. So that is going to give us 112, and this is going to be feet squared, 112 square feet. So when you're talking about area, always make sure you square your units, okay? All right, that's all there is for properties of similar figures. If you have any further questions, please feel free to ask in class. Thanks.